The GX4 is our next generation of industrial inertial sensor. We're releasing and introducing all three basic members, the -15, which is the IMU, the -25, which is the AHARS, and the -45, which is the GPS-INS, all at the same time. The main highlights of the GX4 are that we have a much improved gyro, 10 degree per hour gyro bias instability, which is compared to our GX3, which was 18 degrees per hour. One spec that we don't have in the slide presentation but is on the spec sheet, and that is that the gyros are also much lower noise than the gyros on our GX3, significantly lower, and that improves performance in a lot of areas, especially on the GPS-INS. Cost effective, the prices of the GX4 are the same as the prices of the GX3. We're straight across the board. With that same price, you're getting better performance. It's 20% smaller than the GX3 series, lighter. The power is about the same. It's lower for the GX3 45. It's a little higher for the GX3 15 and 25, but for all practical purposes, it's the same power. We're improving the temperature range. We're going to a full industrial temperature range of -40 to +85 degrees C. The GX3 series was limited to +65 for the GPS-INS and +70 for the AHARS and the IMU. The design is designed to be much more immune to high vibration environments and high shock environments than the GX3. And most importantly, it's backward compatible with the GX3. It's very close to being a drop-in replacement for the GX3. We've maintained all the interface features such that it's not likely to require any or only minor programming changes to incorporate the GX4 in an existing GX3 application. This next slide is showing where the GX4 is positioned in the performance and price performance range. We consider it to be at the high end of industrial grade MEMS sensors. That's typically around 10 degrees per hour gyro performance is one metric that's used for that. But there are a lot of others that put it pretty squarely on the edge of being industrial and almost being a tactical grade sensor. And of course, we are positioned pricing wise to be a very good price performance ratio. Also on this slide shows our 3DM-RQ1, which many of you should be familiar with. It's our first tactical grade product, and it's also a good price performance ratio for that product. We continue to focus on the best price performance ratio in the smallest packages, and we'll continue to do that until we get so small that you can't see it anymore. This is another slide, the next slide, that shows the two classes of device, the GX4 on the left and the RQ1 on the right. High-end industrial and tactical performance. We intend to continue to fill in products in both these performance areas. We're interested in input from our distributors and reps on what their customers are looking for. Again, this just goes over some of the feature differences. I'm just going to take a minute and go over the RQ1 features. The most important being the gyro bias stability, which puts it in a tactical grade. Also, it is in a ruggedized package. It's designed for aerospace. It's DO-160 type requirements for resistance to shock, vibration, environmental solvents, et cetera, et cetera. It uses an aerospace-grade connector on it. Most importantly, our MIP protocol is the same as with every other product, the GX3 and the GX4. So you can just literally unplug a GX4 and plug in an RQ1, and your software continues to work just using a better sensor. We want to make it easy for the customers to migrate up and down in performance based on their needs. So the next slide is showing the footprint difference between the GX325 and the GX425. The GX425 and the 15, the AHRS and the IMU, are in a smaller case than the original GX325. It's shorter by about 8 millimeters. It's just slightly taller, about 0.3 millimeters taller, and its mounting tabs and holes are identical to the GX3 series, so there's no change. The connector is exactly the same. The pinouts on the connector are exactly the same. It uses the same cables, same software, and everything else. One of the advantages of going to this new case is that the GX4 is fully CE compliant in terms of EMC and radiated emissions. Here's just a brief list of applications that we list. Of course, with a general purpose industrial sensor, the list of applications that our customers have put the GX3 in is extensive. But we found that probably some of the most popular, besides just general purpose industrial instrumentation, is camera stabilization, antenna pointing, general platform stabilization, I guess I mentioned that, and also navigation on ground robots and small autonomous devices. A list of how it's different. I've mentioned a lot of these, but I'll just quickly run down. We still think we're the best cost performance industrial inertial sensor out there. High performance, 10 degrees per hour gyro biostability puts it at the top of its class. Small and lightweight. We feel the smallest, lightest device in our performance category. Backward compatible with our MIP protocol, same mounting footprint, industrial temp range, high shock and vibration operation and survivability. One thing I haven't mentioned is a significant feature about the GX4 that makes it stand out over the GX3 is that all the GX4s have a sophisticated Kalman filter to produce estimated outputs. The Kalman filter has its own dedicated processor, and that's in all these devices. They share a Kalman filter processor. The AHRS Kalman filter is an adaptive Kalman filter, which allows users in their application to tune it for very high performance for a given specific application. It's similar to the sophistication that's in a GPS INS, but it's available for AHRS and IMU applications. I want to take a minute just to go over the MIP protocol and features because we think it's an important feature of our inertial devices. We designed the MIP protocol partly because we're users of inertial devices ourselves. We knew the shortcomings of a lot of protocols, and we knew what the requirements were for a good protocol for an inertial device. And this is a review of those features. It's forward compatible and backward compatible. Again, fundamentally, our goal is to make it so you can go up and down our product line and just plug in a different device, and it just works. It has, to assist this, it has a self-disclosing API, which means a programmer can query the device, and the device will give you a list of all its capabilities. in particular what commands it responds to and what data it can provide. And this takes a lot of work out of away from a programmer, just trying to discover what a device is capable of and when features are available and when they're not. Another important factor is we have very strongly typed data, which gives a lot of confidence that when you switch from one device to another, the data quantity you're getting from the new device is exactly the same as the data you were getting from the other device. That is, the data is the same structure, it's the same scale factor, it's the same units, the same range, everything. If it doesn't match, then we come up with a new data type so that you can move between devices with a lot of confidence. Another important factor is the user customizable payload. These devices can produce a lot of data, especially with a Kalman filter. I think we have up to 80 different pieces of data that could be delivered. It's very difficult to get a lot of data through a communications channel unless you're able to individually specify the data rates for each of those pieces of data to optimize your communications bandwidth. So it's fully customizable by the user. We also designed it to be compact and easily parsable, which is important for embedded applications which often have limited resource, such as smaller amounts of RAM, less processing power. It makes it easy for embedded processors to parse all the data that's coming in and act on it. This next slide, again, is a review of the three devices we're introducing all together, the IMU, the AHARS, and the GPS INS. I've gone over most of these features, but there's a few things I want to point out here. First, our standard sensor ranges are the same as the GX3. That is, the standard product is a 5G 300 degree per second product. We have options for 75, 150, and 900 degree per second gyros and 16G XLs on all the devices. I mentioned that the connector is the same as the GX3. That means we have the same USB RS-232 dual communications on the connector. The weight of the devices is approximately 2 grams less than our GX3 across the board. And of course the size is smaller. So this last slide is a review of the top advantages of the GX4 over the GX3. One of the questions we most frequently get asked is if we're going to continue to build and ship the GX3, and the answer is yes. We're still building and shipping GX2s and GX1s, and we haven't stopped shipping those because we have a lot of customers for them. Here's a list of advantages of going to the GX4. We would like people to move to the GX4 because they're going to get better performance for the same price without any difficulty in upgrading. And of course, the gyros are better, the 10 degree per hour versus 18 degree per hour, 20 to 23% smaller than the previous devices. Advanced Kalman filters on each of these. The GX3-45 GPS INS, for example, has a Kalman filter. The processor on that device is not as powerful as the processor on the GX4. It had a 12-state Kalman filter. The GX4-45 has a 25-state Kalman filter. So that's what we're able to do with the newer processor. The temp range is the full -40 to +85. And of course, the MIP protocol is the same. So it should be able to migrate quite rapidly and easily.